So pump drives. Most engine oil pumps are driven in one of two ways, either a rod from the camshaft or directly onto the crankshaft. So some cars run a separate drive that comes off the camshaft. Some, what was very common when we had distributors is that the distributor gear would mesh to the camshaft, and then the oil pump would actually be driven with a rod off the bottom of the distributor. And so that's why if we take a distributor out, sometimes it's difficult to put back in, because that rod, whether it's just a slot or more very commonly was a hex, did not line back up, because that gear, when it goes in, it twists. So when I lift it out, the distributor actually turns. Well, now that it's turned, I go to try to put it back in. It doesn't want to line up with that shaft. So many times we would need to use a socket that we know will not come off of the extension, or a screwdriver to line that up so we can get the distributor to set back in and have it in correct alignment. Some newer vehicles, Hondas and some other ones, made it so the distributor could only go in one way. So the slot was offset, and once it engaged the slot, it would only go in one way. Older vehicles, the slot was in the middle, or in the case of a hex, I could put it in 6 different ways that I could set up, which means that my distributor might be out of time, which means that when I put my distributor in, my car is not going to run because I'm going to be firing the ignition system at the wrong time. And we'll get into more of that when we get into ignition and ignition timing. But so many engines use the pump installed on the front cover, driven by the crankshaft. Very common, especially on Asian vehicles. It's certainly not the only way we do it, but it is very common. And I'm going to mute everybody here, so you guys can, if you guys could turn your mic back on. But I was hearing bells, and I figured you guys were too. If you guys weren't, then I'm concerned. Please unmute your mic and tell me, because it means that I got a problem. But the mount on, and again, if I mount it on the front of the crankshaft, it's usually going to line up with the crankshaft, either with a Woodruff key, or like a Honda will have a couple flat spots on the side. So when I set that on, I got to make sure it lines up and engages properly to turn. We also have what's called an oil pressure relief valve. And the oil pressure relief valve controls the maximum amount of oil pressure in my system. So that is a spring-loaded valve. So when there's enough oil pressure to overcome the spring pressure, it pushes it back, and then oil's allowed to escape. So if I wanted to have more oil pressure in my car, one of the things I might do is change the spring in the oil pressure relief valve, and then I might have 80 PSI instead of 55 PSI, for example. So some manufacturers, some cars, I can change that spring to increase pressure. The issue we have when we increase pressure, and this used to be very, very popular back in the 80s, is that people would increase pressure to the point that they would actually blow the oil filter apart. And then all the oil comes out of the car, and now you need an engine. So it kind of defeats the purpose of all that extra oil pressure to try to make things last longer. So that is something that can fail. The filter is one of our weak links. It is designed to operate within a certain pressure range. Just like anything I talk about, if I modify one thing, I have to take into account other things that might be affected. But that being said, there's times I might want more oil pressure, especially in performance applications or towing applications. So we can see here, oil pressure is affected by the size of the leaks in the system. The oil pressure, because it's a positive displacement pump, it continues to pump oil. It's designed to have leaks in the system. So when we look at our connecting rod journals, my main journals, my camshaft, none of those are sealed. What that means is we're going to squirt oil in there. The oil goes between the bearing and the journal, and then it squirts out on the sides. And that's what gives us our splash lubrication for other parts of the system. So I have to have a certain amount of volume that goes through my pump, and I have to be able to maintain a certain pressure at that volume. If I was to have a restriction, say my oil filter has a restriction, or one of the galleys became plugged, then the pump, because it's positive displacement, would continue to make pressure, we need to have some way to relieve that pressure, and that's what that pressure release does. Oil volume is affected by change in the volume of oil flowing, and the volume of oil flowing is directly related to engine RPM. So at idle, it's not uncommon to maybe have 30, 40 PSI, but when I am going down the road and my engine's at 2,000 RPM, maybe I have 80 PSI. So the pressure is going to change as my engine speeds up. Well, if I have 80 PSI at 2,000 RPM, what happens when I'm at 4,000 RPM? I don't want 160 PSI. I have to have some way of relieving that extra pressure, and that's the pressure relief valve. So that is normally built into the oil pump, although not always. Sometimes they're in the oil filter extension housing by the oil pump and some other places. But many times it's actually built into the pump itself.
Release the pressure on the oil pump.
It relieves the pressure, right? It just allows it to circulate back to the oil pan.
Oil pan, okay.
So it's just dumping it off so that we don't damage other things or blow other stuff off. So that's why it's normally, it has to be either in the oil pump or somewhere between the oil pump and the oil filter. Because I'm not going to put a pressure relief valve after the oil filter because that wouldn't protect the filter. So many times this is a large nut, about 19 millimeters around, 17, 19 millimeters around, that has a sealing washer on it, usually copper or aluminum, and is mounted on the oil pump, or if it's on the front timing cover,
right,
it's mounted on the front timing cover. That's actually the oil pressure relief.
We can see from under, when we take off the oil pump, usually we see this valve.
Right, yeah. If the oil pump's sitting down, you see that big nut on the side of the oil pump, that's the oil pressure relief valve.
Okay.
You got it.
I mean, I have a little bit of experience, you know.
Well, it's always good when I can tie something I'm talking about or showing pictures into something you've experienced, because that means you're putting together what you see with understanding a function, and that's sure. Huge. And unfortunately, that's really hard for us being here in our houses or our cars.
Right, especially with this job. I mean, you want a dirty end, you know what I mean, for understand. It's okay.
Believe me, it's challenging from my end too to try to explain it. So here an oil pressure relief valve stops excess pressure from developing. You can see the little spring. This is a pretty good cutaway, much better than what the old book had. And it shows that as we produce more oil pressure and more oil volume, the volume is what makes the pressure. Because you think about a garden hose. I have a lot of water going out the hose, but not very much pressure. What happens when I put my thumb over the end of the hose? Is there now pressure in the hose? And my dog loves the hoses, so that's usually when I find out where she bit a hole in it. And then I got water usually spraying me somewhere. So again, we have a lot of volume. What makes pressure is the restriction. So that's why as an engine wears or engine bearings wear, we might have less oil pressure. So because the tolerance, we're designed to have a 3,000s clearance. Well, what if now I have a 4,000s clearance? That's more oil volume that I would need to flow. That's also more oil that's going to leak out the sides. And so therefore, if my oil pump can't make that volume, we're going to lose pressure. Where is it located again? The oil pressure relief valve, like on your Honda that we did the oil pump on it. So it was right on the front of that cover, and it was the large steel nut or bolt, basically, that was screwed into that oil pump cover we put on your car. And I think it was a 17 millimeter on yours, was the hex head on it. But that was the thing I said, don't take off. That's supposed to be there. Just, leave it. But that's that oil pressure relief valve. So, like I said, it's always good when we can put stuff together, because when we replace a part, we're not always thinking about all the functions of the part we're putting on. And so it's good when I can go back and do this and tie that in with experience that people have. So oil filters. After my oil pump, I want to go to the oil filter because I want my filter to collect all my large contaminants so it doesn't get into my bearing surfaces and damage the bearings. So two basic types of filtering: full flow filter, which we have in image A, and a bypass filter, which is in image B. So it kind of depends. So the pleated filter, paper filter, and medium. So most systems that we use is what's called a full flow filtering system. We want to filter all of it through the filter. That being said, if the filter plugs up, it has a bypass valve inside the filter. So say someone goes, you know what? I haven't changed my filter in like 15,000 miles. It's fine. My car is still running. Well, that filter might have plugged up at 8,000 miles. And then the bypass valve inside the filter or next to the filter, we can see a bypass filtering system here, no longer sending oil through the filter. So now you're driving a car with no oil filter. But you're right, you got away with it for 15,000 miles. You probably got away with it for 90,000 miles. You're not going to get away with it for 130 or 150,000 miles. I can't tell you how many cars I've seen come into the shop, 80, 90, 100, 120,000 miles where the engines are just destroyed. And these are people that usually stole money on the car, and they haven't taken care of the car. They haven't changed the oil because they're tight on the money. And now the thing they stole money on that they need for transportation has let them down. And usually the first thing I hear is, I bought this because I thought these were good cars. Well, they were good cars until you destroyed it. You know, so like we talked about yesterday, the cheapest thing I can do to make a car last a long time is change the oil, change the filter. You know, as recent as, I shouldn't say recent, as recent as the 1950s, oil filters were optional. They were not part of a car. That was an add-on that you paid for. And even into the 60s, we would see people that would add on an oil filter to their car. And one of the common ones actually used a roll of toilet papers. Anyone ever seen one of those? They actually had it was a chrome or stainless canister mounted on the fender inside, and it had two hoses that went down to the engine, and the filter was actually a roll of toilet paper. And you would open it up, put the roll of toilet paper in, take it up, close it up, run the car, and then when it's time to change it, you'd take that oily roll of toilet paper out and put another one in. And it actually, when you think about it, filtration is all about micron level. It's all about how small of a particle can I filter out. Do you think a whole roll of toilet paper, by the time we flow something from the outside to the inside, is going to really filter out a lot of stuff?
Toilet. So they use a filter as toilet paper as a filter.
Yep, there was a kit. Fram is the company that sold it. You guys have probably heard of Fram. They're still in business. And it was a add-on filter kit. We saw them a lot on 60s cars, 50s and 60s cars. This is when we didn't have necessarily good filtration from the factory. And that was the whole market, was people were adding oil filters to the cars, and these particular ones used a roll of toilet paper. Pretty amazing, isn't it?
Actually, yeah.
But you think about it, we filter water, right?
Yeah.
So, you know, when we filter water, one of the most effective filters for water is sand. Did you guys realize that?
Yes, the metal is like sandal, no, inside the engine.
Yeah. So sand is a great filter for water. We wouldn't want it for oil necessarily. So the other is, I see a couple of you have seen it. Again, it's the concept of very small passages, things going through a lot of it, and then finally finding that. So let's see if I can pull that up here. I see a couple people asking to see it. Let's see if I can find this frame. Came right up. There we go. Images. There we go. Okay, so let me share this. So here is our Fram toilet paper filter kits. And here's one right here, the France toilet paper filter. A couple of different people make them, but instead of a roll of toilet paper in here. And here's the Fram bypass kit right here. That's a fuel filter, ignore that. But here's kind of, you can see what it looked like. Here's the toilet paper oil filter, and it actually held a roll of toilet paper in it. There's a guy putting the roll in. He's trimming it down, getting the excess toilet paper off if it's too big around. Pretty amazing, huh? There's a picture up here. I'll roll of toilet paper right inside the filter, and we're going to run our engine oil through it. And you guys thought I was making this stuff up. And here's the top of one. You can see the passages. So there's, you know, like I said, then we've moved on to other oil filters. But you can see this right here. I bet you there's probably even a YouTube video on it. So everyone learned something new today.
I did.
For sure.
What's that?
For sure.
So yeah, and you know, like I said, are there still some of those on the road? Yeah, occasionally you still see some around. I get surprised every time I see one on a car still. But the point is it all comes down to filtration and thinking
No,
about
nos acaban de
filtration.
enseñar unas imágenes de donde, o sea, un filtro, o sea, es un filtro con papel. ¿Quién diría? No, honestamente,
Pablo.
Yeah, he keeps turning on his microphone and then he talks or I have noise. I just turned him off again. So pleated paper, right? So toilet paper, we know what kind of comes apart. So these are a little heavier paper. When Mercedes went to 18,000 mile oil changes on their S-Class, the paper filters were actually coming apart at around 12,000 miles. And they actually went to using fleece for their oil filters. You know, fleece, like you get a fleece jacket or that type of thing. Actually, a fleece, a cloth oil filter cartridge, so it wouldn't
does that
break
mean,
down at
fleece?
18,000 miles. What's that?
What does that mean, a fleece? I don't know
Fleece.
this.
Fleece is a material, and it is a material that we make jackets out of that are really warm or sweaters. So
Like made of a plastic, made of a.
no, not really. It's actually a linen. So, you know, so fleece could be made out of a lot of different things. I could make fleece out of cotton. I could make it out of wool. I could make it. So it's more a style of fabric, I think. You're going to make me Google this, aren't you?
Maybe. Thank you. Thank you.
I'll spell it wrong. Oh, there we go. F-L-E-E. And let me go and we'll share this and let's see. Come on. So here I just Googled fleece. You can see fleece fabric. So, you know, coat of wool or a wool bearing animal such as sheep will obtain shearing.
Okay.
So fleece. So here's some fleece right here. Fleece is normally very, very soft.
That sounds like a bar.
So do you understand fleece now, Mario?
Yes, thank you.
You bet. Well, I always figure if you're asking the question, there's at least 10 people with the same question that didn't ask me. So I always figured I'd rather take a minute and explain it because I don't want to lose anybody, but I want to show that all filters aren't the same because the book's just showing the paper here. Mercedes had a technical service bulletin talking about using only fleece filters on their S-Class with the flexible service system because they had that. So we have two different kinds of filters, a spin-on filter, most common, and use it as a one-piece filter assembly with a crimped housing and threaded base. The square cut rubber O-ring fits into the groove of the base and the filter seals the base to filter the engine block. The other kind of filter we have is a cartridge filter. uses a separate removable metal or plastic housing and a replaceable cartridge, held together with a threaded center bolt or screw-on housing. So early, if I go back to the 1950s, everything was a cartridge paper filter. Or a cartridge filter of some kind. Some of them weren't paper. They actually had like steel wool in them, and you'd pull them out, clean them, put them back in. Volkswagen did that also on their on their some of their stuff, where they use a screen. And then we got into the paper filters. We used those a lot, and then we went to spin-on filters, and we did that really in the 60s. And there was actually conversion kits for like Chevys to convert the old cartridge filter to a spin-on, because a lot of times you do the cartridge filter on a small block Chevy, it would leak after you're done, or you wouldn't get the seal just right. They were not nearly as good as they are today, or as good as the European ones are. And we kind of saw a movement, although a lot of European manufacturers held on to the cartridge style for the paper filter, we did see a lot of engines go to the spin-on. And then about 20 years ago, Europe said, we don't want spin-on filters anymore. We only want cartridge filters. And so currently in Europe, spin-on filters are not legal. You can't, put those on new cars. All the new cars have to be a cartridge filter because they're concerned about environmental waste. With the cartridge, the only waste you have is the paper cartridge. With an oil filter, there's all the metal, which is steel, which can be recycled. In this country, we normally recycle it into rebar, is the most common thing it gets recycled into. So it can be recycled, but the Europe's idea on trying to control environmental waste is that you can only have paper cartridge filters in Europe, or fleece cartridge, but only a cartridge filter. So we're seeing a move now, and you see this with Toyota and other Asian manufacturers, where they're going to that replaceable cartridge filter and not a spin-on. So we're seeing where, the industry started someplace, moved to another place because it was more convenient, more efficient, and then we're back
Went back.
started for environmental reasons. So it is interesting how, what's old is new again. Isn't that the same? So it is fascinating how that changes. So filters, are all filters the same? No, they're not. So as we open up filters, we can see there's a big difference in how they're constructed, even though they fit the same application of vehicles. So your $1 or $2 filter is not going to necessarily be the same as a $6 filter or a $12 filter. So what they put in the filter, how they build it, has a direct impact on the amount of filtration it's going to give. Also, how and based on how much paper is there affects the micron level. So am I only getting out particles that are 20 micron? Am I only getting out particles that are 50 micron, or am I filtering out particles down to 5 micron or 2 micron? So a micron is a measurement of the diameter of something. To put in perspective, pollen, normally about 10 to 20 micron is how big a piece of pollen is. So, again, how big of impurity am I worried about? Obviously, the better filtering, the less of those impurities are going to get into where my bearing journals are, the less wear I'm going to have on my engine. So, filters is something that we definitely need to look at. I know Wix, which is Napa, used to have a cutaway of their 3 different levels of filter. And actually, you could not only see, but it also pointed out the differences between their economy, their mid-grade, and their gold or their premium filters. And you could actually see the internal difference there. So you could make a decision on what you want to run on your car. So it's not just, don't think that because I bought it and it says STP or it says, super duper on it, that's the best filter. There's not that many companies that make filters. Unfortunately, a lot of filters now are made in China. And we definitely see, we've had some severe quality issues with some of the Chinese filters. That being said, it's hard to get filters not made in China right now.
I buy always original OEM parts.
Yeah, and some of that's made in China, which is really horrible. If I buy a factory AC Delco filter, it's made in China. and
bad
that's,
quality.
which is horrible,
Oh, wow.
you know. And we had a lot of problems because we carried AC Delco for a while because we were a GM distributor, and it would actually on the Toyotas, the seam was blowing at the crimp to the base of the filter and was blowing out and causing oil leaks. So we're using what we felt was a premium filter, AC Delco, and you know, they came in and did it, and it did it. I need to do a startup company called Super Duper. I agree. That's the $1 million idea right there. Which filters are worth buying? Great question. Mario's right. OE filters are good if I'm buying a factory Mercedes or something like that. If I'm using a European vehicle, I'm probably going to use a Molly or a Man filter, or two of the ones that generally they make them for. So Man.
I know Men.
What's that?
No, I know this brand, Men.
Yeah, Man, MANN, and Molly or Miley, however you want to pronounce it. So those are a couple of them, and there's one other one that's a Euro company that we use. I apologize, I'm blanking on it at the moment. That also is an OEM provider. So I'm not, like, in my shop, we did a lot of European work. I didn't buy filters from Mercedes or BMW. I bought them from Man or Miley or the other company I'm blanking on, because that's who makes them for Mercedes or BMW. That being said, if I'm working on a Ford diesel, like a 6-liter, I'm only putting a Motorcraft filter on it because the aftermarket ones are not correct. And there's actually technical service bulletins about using aftermarket filters, even from brands such as Wix, WIX, which is a premium filter company. Wix is who makes them for Napa. They make their own label stuff. They make Servitiers. They're a huge filter company. They make a lot of stuff. Purelator is another big filter company. And both those companies make a lot of stuff under other labels. So it's always good to kind of take a look and see. I'd rather buy something that says Wix or something like that than something that's a brand name, you know, like Super Duper, that really attracts me into it. Well, who's making that filter? You know, I'd rather pay for the manufacturer's name or a company that I know makes a good filter versus a marketing name. And like I said, Wix makes them for Napa. They also sell them. I think O'Reilly sells Wix. A lot of companies sell Wix. Probably, I wouldn't be surprised if they're the biggest single filter manufacturer. I use a lot of Wix stuff. That's what I use in most of my stuff. Wix makes filters for AMSOIL. They make filters for other, so they also do some custom filter stuff. They're a huge company. You know, it is hard. Also, how long is the filter going to be there? 3,000 miles, 5,000 miles, 10,000 miles. You can get away with a lot more at 3,000 miles than you can at 10,000 miles because of how that's gonna, the filter or cause issues. So, you know, currently right now I'm running the Wix filters. That's what we stock at the shop because we're a Napa auto care center. And so when I go in to teach my class at the shop, I do my shopping and pick up my filters and pick up that stuff and let the boss know. Take pictures, send them a picture, and let them know how much shopping I did off the inventory shelves. So, you know, when I go buy coolant or I need any of that stuff, I buy through the shop, or if I need parts, I just order them through the shop normally and have them delivered that way. But I've used Wix filters, 35, 38 years. Good filters, you know.
BMC is
But I
like
wouldn't buy a Wix filter for your car, Mario, because they're going to rebox something else. I'm going to pay 2 or 3 times what I'd pay for a Man or a Miley. I'm going to go straight and get the European one if I'm working on a European car. I'm not going to buy a Wix filter for a European car. They're way overpriced.
Men or Bosch?
Bosch is okay.
Men is for German car, but
Yeah. I mean, Bosch is an aftermarket provider. I've certainly used Bosch filters, especially the spin-on ones on like the single overhead cam, 6-cylinder Mercedes, and some other ones. We used a lot of Bosch filters because Bosch was actually OE for them. So the spin-ons, the European spin-ons, I use a lot of Bosch. But and I'm not hesitant to use the Bosch products on the European spin-ons. We don't use a lot of Bosch on the cartridge. And I don't know if it's because they don't sell them or a price point. Is it a good idea to buy filters from the dealer? It might be. Sometimes you can get a filter from a dealer, like a Toyota filter or something, sometimes cheaper than you can buy it at O'Reilly's or another aftermarket auto parts store. So I wouldn't say not to buy it from the dealer, but on the other hand, if the dealer wants $20 for a filter, you know what? And I can buy a premium aftermarket one for $8. I'm not buying it from the dealer. But a lot of times oil filters, you know, like Honda oil filters, Subaru oil filters, a lot of times they're very, very price competitive, where they're same price or sometimes even less than what I'm going to pay for a lower quality filter at the parts house. You know, we don't want to overpay, but we want to get what we pay for and understand what we're buying. And unfortunately, because especially if I'm buying a cartridge filter, all I do is I look and see the shiny outside. What we're normally not doing is looking inside. We're not looking at the paper. Does it have paper pleats this far apart, or are they this far apart? Is there a valve that I'll show you coming up at the back of the filter that retains oil in the system? So some filters allow oil to drain back from the top of the engine to the bottom. Other filters have a little check valve in them that when I shut the car off, it keeps oil in the top part of the engine, in those galleries going up to my camshaft and to my timing chain tensioner. So when I start the car, I don't have that 10 seconds or 5 seconds without any oil. So for example, Hondas use a check valve in their filter. Good aftermarket filters do also. But Honda had an issue on their V6s where people were putting on cheap oil filters and causing damage to the camshafts and causing variable cam timing noise because the oil filters were draining back, and it was actually setting misfire codes. So cars were getting misfire codes, P0303, 305, whatever, because someone put a cheap oil filter on a car,
Wow,
allowing the oil to drain back.
You can go crazy to find this stuff.
Right. And that's why it's important to understand, and I'll talk about this when I get into OBD2, that a misfire code doesn't mean the engine's misfiring. It means the computer saw something using the sensors it's using that fell out of a certain parameter, and that's what it was told to say. Right? So it was told to say it's a misfire. Does that mean it's a misfire? Not necessarily. A lot of things can cause that. And then when we get into OBD2 and the computers, we're going to drill that down a little bit and have some fun with that. Because that gives people a lot of trouble. They take things very literally. Oh, it says it has this. No, that's just the code it was told.
This is like
you have a kid.
A square way to think, you know? If you think a little bit wide, you can understand. It's like I think all the technical problem. It's like you have to think outside of.
Boy, you're 100% right. You got to look at it wide. You got to think out of the box. You got to think, if I was a computer, what did I see to think I'm misfiring? And why would I say that? From there, we can figure out the problem. So we got to ask a lot of whys. Remember what I told you guys when we were in the classroom? My job is to get you to ask questions because I can't give you all the answers. And questions are great because we can use them around the house. We can use them if we're cooking. We can use them if we're fixing something at home. We can use them with anything, because once we start asking questions, then what? Then we start looking for answers. So oil galleries, the main oil gallery runs lengthwise in the block and connects to most other galleries. The passages of the main gallery are drilled into the main bearings. The crankshaft is drilled to carry oil from the main journals to the connecting rod journals. So we have this passages of oil that when we pressurize it, it's going to pass through the crankshaft It's going to go up to my camshaft. It's going to go to my timing chain to help the timing chain tensioner. So we send oil throughout the engine. I got to have a way of getting it there. So I have passages. Kind of think of them as internal pipes, but we call them oil galleys or oil galleries. Some engines use separate oil lines to carry part of the oil flow. We can see this both internally and externally. Some engines use an oil tube on the inside to carry oil. Other cars like Toyota on their 3.5 liter that they used on their Camrys and Highlanders and all that stuff actually had an external oil line for each cylinder head that would go from the outside and go over to move oil around to get oil up to the camshafts and up to the cylinder heads. So Subaru uses external oil lines to move oil around. So I can have internal oil galleys. I can also have internal oil lines. I also have manufacturers that are currently making cars that have external oil lines. And just like any oil line or any connection, we can get leaks and blockages and so on. A lot of times, like in the case of Subaru, these external oil lines actually have a filter in them. Same with the Mazda on the Miata. Their external oil line has a filter in it. So not only do we have the filter in the that we spin on, that we service, on modern cars with variable valve timing, there's also often filters elsewhere in the oiling system to keep small particulates that the oil may have picked up since it left the filter from getting into the variable cam timing system and causing the spool valve, which is our solenoid, or our actuator on the camshaft, either be damaged or not work properly. So others have tiny holes that line up with a crank journal once every revolution, which are split holes, where it's pressurized all the time, but it has to turn around at just the right spot for oil to be squirted in. So here's a picture I have on oil flow. We can see on the left side, it pulls up from the oil strainer into the oil pump, into the oil filter, through the galleries. We have the oil cooler there. And then after we've lubricated the bottom end, we move up to the top end. So on the right-hand side, I have a flow chart of how that works. So we have the oil pan, goes up through the oil strainer to the oil pump. We see we have the relief valve right off the oil pump if we have too much pressure. Then there's the oil filter, then the oil cooler, then the main oil hole, main oil gallery. For the main oil gallery, which is the main oil hole. Now we're going to feed the crankshaft, connecting rods and pistons. And then you see the arrow going back down. So after it feeds these things, what does it do? It sends oil back to the pan. So the oil is constantly circulating. And we need to constantly circulate because we're using oil for cooling. So I want to get any contaminants out of there. Plus, because there's so much force, that 1,000 pounds per square inch in there, that's creating a lot of heat on that friction. We want to get that oil out of there, so we constantly want to be putting new oil in. Also from the main oil, I have passages going up to the left and right cylinder heads. From there, we go into the camshaft journals. Then we go into the camshafts, the valve lifters and valve stems. And then last thing, it calls them here scissors gear mechanism. That is our camshaft actuator. So our camshaft is the last thing to get oil. Our lifters are the second to the last thing to get oil. Because if my lifter is low on oil, it's going to start making a ticking sound. If my camshaft actuator or scissor gear mechanism is low on oil, I'm going to get codes. But if my camshaft is low on oil, it'll seize up, stop turning, and be damaged. So you see, we want things that are either going to turn on the check engine light with a code, or in the case of lifters, start making noise to warn us there's a problem before we have catastrophic damage to the engine. So that's why we flow oil that way. So according to the diagram on the previous slide, which component is the last to receive oil pressure? Okay. And here's our full pressure engine oiling system. A little different picture. We can see kind of a blow up on our last picture here. We can see the oil coming in. We can see it going to the oil filter, and that goes down and supplies the crankshaft. And the little lines you see inside the crankshaft are kind of the illustrations of the inside passages of the crankshaft. Then we feed oil up to the top end to the oil changer. And here, this particular card says oil spray nozzle. So that's usually the return. So the returns for some of our pressurized oil kind of gets sprayed out to where the timing chain is, because the timing chain is splash lubricated, not pressure lubricated, where the tensioner uses pressure to work, camshaft journals are pressure, but my rocker arms, if I have rocker arms, they're splash lubricated. There's no oil pressure on them. So things with less force on them, less friction, we can get away with splash lubricating them. Things with high amounts of friction, high amounts of force, then we'll need to have pressure lubrication. So yeah, at the top, the camshaft's gonna be pressure lubricated. Here they're drawing the camshaft as being a hollow camshaft, where there's an oil passage going down it. Some camshafts will have an oil passage going down the camshaft to lube it. More commonly is that the cylinder head actually has the passages into it and the camshaft does not have passages. But, you know, one thing, engineers can design things a lot of different ways and continue to do so. Oil enters the bearing. The bearing receives oil from a hole drilled through the bearing support. Insert a hole that aligns with one of the bearing supports. Oil passes through and engages the turning journal and is pulled around between the insert and the journal. The oil constantly forced through the bearing, so we're constantly moving it. And again, going back to the picture we saw yesterday, I just moved it here in the presentation, where we start off with very little oil in here, and we actually have metal to metal contact, or a very, very thin amount of oil between the two pieces of metal. And then as oil enters, it starts to center the journal in the middle of the bearing, and they don't touch. So you can see why it's real critical to be able to get oil pressure very quickly. And we want to make sure that we have oil there. So they talk about, which is important for right now, we're having cars that are sitting for quite a while, aren't we? You know, some of us aren't driving our cars very much. It's still important to go out and start your car at least once a week, fire it up, let it run, build oil pressure so that we get some oil into these journals so it doesn't all drain out. So if we start the car after a month or after 2 months, that we don't do more damage than is necessary to the engine. And here's a picture. This is from your book, where you can see the connecting rod. And the connecting rod has two halves. It has a lower half and an upper half. So the lower half is called the cap. And you can see the blow up in here where it's showing the hole where oil can be go through. And this one has they're showing the squirt hole here where it's positioned to squirt the excess oil after it's used to lubricate the bearing up onto the sides of the cylinder wall. Heavy duty engines may have oil nozzles that spray oil onto the bottom side of the piston to help cool it. Oil is fed into the cylinder head through oil galleries and on the camshaft bearings and valve train, and the oil drains back to the oil sump through oil drain back holes located in the cylinder head and engine block. On a lot of four-cylinder cars or smaller cars, they're actually making them so they all drain back over the timing chain, and that's how they lubricate the timing chain. Other cars may have passages going on, or they may have multiple passages. Here's our filter operation. It's a little bit out of order. I need to move these back over the filter, but it looks like here's a regular spin-on filter. You can see here the oil is forced into the outside and it comes out the middle. So some filters come wrapped in plastic, and what you should never do is put your finger in the middle to knock the plastic out, because the plastic may end up inside the filter, which means that then that's going to get pushed into your lubrication system. And I've actually seen engines destroy the cylinder head from that because it gets caught going towards the camshaft. They have a real problem with it on the Honda 1.5 liters. Yes, I will post the PowerPoint. This PowerPoint presentation is in Canvas. It is, let me give the section on it, excuse me for a second, because I did post this. So let me. Uh, 6.1, ooh, my bad. I posted it, I did not publish it. Sorry about that, you can see it now. I did get it up there, I just didn't turn it on. Details, right? Sorry about that. That's why it's always good to ask. So here's a deep filtration oil filter. You can see here the difference in the media. So again, these both are going to fit on the same housing. They're both going to screw on the same car, and but they have different levels of filtration. I see a note here that Frank used a smoke machine to show oil flow. That's a great way to show it. And the thing that's really neat about using the smoke machine for that is that not only you can see where it goes, but you can also see it's not sealed. And so where the smoke's escaping is where oil is escaping, because it's not a sealed system. But yeah, smoke is very effective for doing that. So oil seals. Oil seals retain oil in the engine. Gaskets are used throughout the engine. Sealants, such as RTV, room temperature vulcanizing, silicone, or anaerobic sealants. So anaerobic sealants are normally used on some European manufacturers specify those. Normally it's, we only use them during engine assembly, and it's for different cast pieces of aluminum that we're putting together. They'll specify an anaerobic sealant and not a silicone. You don't want to use silicone in those applications. The silicone will be too thick, and you can actually damage the components or create a sealing issue. RTV, not all RTV is equal. You need to make sure you use RTV that is what's called sensor safe, meaning O2 sensor safe. Regular silicone RTV off gases, you can smell it. Automotive silicones that are O2 sensor safe will not off gas, so you won't smell the silicone like you do. If you've ever dealt with like aquarium silicone or anything like that, it really has a strong smell to it. That off gassing will damage the oxygen sensor on the vehicle and ruin it. So which in turn can cause damage to the catalytic converter because of lack of fuel control. So if we're using silicones, and unfortunately auto parts stores sell a lot of cheap silicones that are not O2 sensor safe, you can get away with using them for things such as a water pump because it's only a coolant surface. Off-gassing is not such a problem if I'm dealing with cooling system or a thermostat, something like that. But if I'm dealing with anything that is open to the engine oiling system, I cannot use a silicone that is not O2 sensor safe. Otherwise, I would damage the O2 sensor. So, like I said, unfortunately, auto parts stores sell all kinds of $1.99 and $2.99 silicone that's not oxygen sensor safe. Matter of fact, I get kits and other things, or like when I get a differential kit and it comes with silicone, the silicone it comes with is normally not O2 sensor safe silicone. It doesn't have to be. I'm sealing up a differential. The problem is people have that silicone left over and, oh, I got to do valve cover gaskets and it's black silicone, so it'll look just fine. I'll use it. And they inadvertently damage the O2 sensor. So it's really important to use the correct silicone. Oil seals are placed at the front and rear crankshaft. I also have oil seals for the camshaft. I may have oil seals for the oil pump drive. So, you know, generally we talk about gaskets between two pieces that don't move, where we use a seal where one piece is moving, normally rotating, and the other piece is stationary. So oil seals will get hard, gaskets will get hard. I talked yesterday about the importance of changing oil so that we can get maximum life out of those. If we don't change the oil, the gaskets will prematurely get hard and they will leak prematurely. So here's an oil pan gasket on the left-hand side there. The oil pan gasket can be just silicone. Some manufacturers specify just silicone. Some of them use a rubber that or a silicone type material with steel impregnated in the middle of it. If I go back in older cars, I might run across cork gaskets, where we use cork for a lot of gaskets, or paper. I might have paper gaskets. Europeans used a lot of paper gaskets. So I can use a lot of different things for gasket material, and cork and paper are going to work fine as long as the gasket is correctly torqued. Once the gasket collapses a little bit and the bolts loosen up, then it's no longer properly torqued and allow oil to get past it, and then we have a leak. And as the oil gets past it, then the paper or cork will deteriorate. So it's important when we tighten this stuff to use proper torque. You know, I know this isn't a transmission class, but automatic transmission pans is one of the few things that I use a torque wrench on every time. Because if I don't use a torque wrench on it, they leak. When I use a torque wrench on it, they don't leak. And since I don't like getting yelled at by customers whose driveway's now a mess, and my boss who has to eat materials because I'm redoing the job, I found that torquing pan bolts like this is huge as far as preventing a comeback or preventing a problem. Because a lot of times these are small bolts and they're very, very easy to over torque. And if I tighten them up too much, I can either A, break the bolt or strip it out. But more likely, I'm going to compress the gasket and possibly distort the oil pan, especially if it's a steel oil pan. I would distort the oil pan to where then what's happened is instead of the oil pan being flat, it actually will have a spot that's risen up like this in the middle. Well, as it's risen up in the middle, guess what? There's less gasket material here, so it wants to cut the gasket, and then the gasket material over on the side where it's thick isn't being properly pulled together, and we'll get leaks there. So it's really important if we're changing an oil pan to make sure the oil pan's flat. Many times if someone's been there before you, the oil pan, if it's a steel oil pan or steel valve cover, it will not be flat. We actually take a hammer and a piece of steel and we actually reflatten it and make everything nice and flat before we put the new gasket in. So we're actually making that metal so that surface is nice and flat. It's not raised out or humped where all the bolts go through. And that way, when we put the new gasket on, it'll adhere. I may want to use silicone along with a cork gasket to hold it in place. If you do that, you only put silicone on one side of the gasket. Normally the pan side, not the engine side. This is done for two reasons. One, so I can clean the silicone off much easier off of the pan than I can off the engine. The other is if I put silicone on both sides of something like a cork or paper gasket, the gasket itself is no longer doing the sealing. The gasket has become the weak spot. The other thing is because I have silicone on both sides, silicone slippery, the gasket will actually move or pooch out, causing a leak. And so that's why we only put it on one side so we can use the silicone to hold it in place. But when I attach it and go to tighten it, the side that does not have the silicone on it will adhere to the engine, not move around, and provide a good seal. The other thing is if I'm replacing any gaskets, oil pan gasket, valve cover gasket, I need to make sure that both my surfaces are clean and dry. So I need to make, and by clean, I mean like razor blade clean. Yeah, Mario.
No, you mean like the best way oil, it's like a tiny bit of silicone in this.
Yeah, tiny bit of silicone.
Just to hold the gasket.
Just to hold it, an 1/8 inch diameter.
All right.
1/8 inch diameter bead. Even if I'm just going metal to metal like aluminum, 1/8 inch diameter bead is really all I need. I shouldn't have gobs of silicone sticking out around what I put together. I can always tell when someone did the job at home and not a shop because there's gobs of silicone coming out and it's usually red. I don't know why over the counter. Maybe it's on sale at the local auto parts store. I don't know. But you can look and see. It's like, oh man, someone's been here who didn't know what they were doing.
The auto part explain like that for sale, more silicone.
Yeah. I think a lot of people think of a little bit's good, a lot's better. You know, there's different brands of silicone. Probably the best silicone for sealing things is called The Right Stuff. And that's the name of it, The Right Stuff. It's made by Permatex, which is a huge manufacturer of silicone. You
It's
don't
hard
want
to forget.
the person that has to clean it off when you're, if the car ever comes back, but it does not leak. You can put it on stuff that's not as clean as you'd like. It'll still seal. A lot of silicones, if there's any oil on the surface, the silicone has zero adhesion. So it'll leak right past it. No matter how much silicone you put on, The Right Stuff will not leak. It doesn't have the same dry and skin time. Honda Bond is good, except for a Honda Bond, they say they want at least 12-hour cure time on it. And it's about 18 bucks a tube last time I bought some for doing a timing cover. But Honda Bond is good silicone, but it has a very long cure time. It does hold up quite well. It's gray. But like I was putting together an engine, and so we put the Honda Bond on the timing cover and the oil pan, put it all on the day before, and then waited overnight until we put oil in it. So we started it up. The mistake people make, because Toyota also has a factory silicone very similar to that, the mistake people make of these is they don't give them adequate dry time. And what has to happen is the silicone has to, what's called skin. It has to actually get a dry coating on it, even if it's not dry all the way through. It has to get that dry coating on it. If it doesn't get that dry coating on it, and then I expose it to oil or water or whatever, then it's never going to cure. And if it doesn't cure, it's not going to prevent a leak fully, especially with oil. So The Right Stuff's pretty slick. I have some in my office at the school. They didn't have it at all before I got there. I kind of keep it under lock and key so we can use it when we need to use it on a project, but it doesn't just disappear. But it does, you can get it a couple different ways. You can get it in a Cheese Whiz can where you actually just tilt the can and it lays it out. You can get it as a caulking gun if you're using a lot. So they have different ones and different sizes of it. But we use it a lot for differential work, a lot for transmission things. You know, gear oil is hard to clean off of stuff. A lot of times the differential will continue to drip stuff out of it because it has a lot of oil that's collecting. So instead of waiting or risking a leak, we use The Right Stuff. We can wipe it, slap it, put it together. It doesn't leak.
The differential is pretty thick, the oil on the differential.
It is, but it'll still leak like crazy. And because it's thick, it really impregnates the metal really well, makes it hard for the cover to stick. And like I said, we use The Right Stuff and we slap it on, wipe up any trim, and we're putting oil in it right away, shipping the car, it doesn't leak. And you can always tell when someone's used The Right Stuff because if you've got to take that cover back off, you need 2 pry bars and the cover wants to bend instead of just pop it up. I mean, it is very, very glued.
If you use like a knife, like a cutter, before you use the pry bar, you know what I mean?
Yeah, you do. I have a long putty knife with a blade on it that helps. But let me tell you, once you've taken something off with The Right Stuff and had to clean it, you got to wire wheel it all. It doesn't just peel off. You really understand the difference of how much better it seals. So I don't use The Right Stuff for everything because there's places I don't want to go through that much of a mess again. If I'm taking it apart, I don't need it. There's other places that, oh, absolutely, I'm using it. I do not want to do this job again. I don't want this job to come back. I don't want this job to leak. You know, this car has 180K on it. The original one lasted 180K. I use The Right Stuff. I want it to last at least another 180K. I'm never taking this back apart again. It's getting the right stuff because I am not taking it apart again for free because of failure of silicone. So, but there is a lot of products out there, but I do mention the right stuff. And it's so funny because I'll tell my students in the lab, go tell Angel that you need the right stuff. And it just drives them nuts. I got to walk up right here, the right stuff. Oh, well, they didn't say that. Yes, they did, Angel. Angel retired. He won't be there when we get back, I guess.
I'm sorry.
Yeah, he was set to retire in June. So I think he's retiring.
I ask a lot of stuff to Angel. He know a lot about car.
He does. He
Look like a person who know, like, because he did. You know what I mean? It's
right?
like a reliable font.
Yeah, he knew a lot of ways to get things. He'd been there 35 years. So he finally retired, and I think Tim also retired. They were both offered a retirement package. The district offered people that have been there over 25 years a retirement package. So it'll be interesting when we get back. We'll be shorthanded. So I don't have Jessica. Doesn't look like I'll have Tim. Doesn't look like I'll have Angel. So it'll be interesting. Apparently, I'll just need to work more.
Give him 1 week with his wife.
Yeah.
And he'll return.
Yeah, Angel's not married, so.
Oh no.
Tim is. Tim is. And I don't think Tim wanted to retire, but I think his wife said so. So on the right, we have our front and rear crankshaft seals. Also, many times this is called the main seal. So if someone uses the term the rear main seal, they're talking about the rear crankshaft seal. Rear crankshaft seals come two different ways. Either there's a two-piece seal or a one-piece seal. If it's a two-piece seal, it is replaced by taking the oil pan off. And half of the seal goes in the main bearing cap, and the other half of the seal goes up inside the block. And they surround the crankshaft and they get squeezed together, which creates a seal. And those can be silicone or rope. And if they're silicone, they're normally metal reinforced. The other kind of seal we have, which is a much better seal, and we see on newer vehicles, is a one-piece seal. One-piece seals are replaced by taking the transmission out. So on a one-piece seal, we take the transmission out, we take the flywheel off, then we replace the seal. On a vehicle that uses a two-piece seal, which is going to be older domestic vehicles, other vehicles also did this, you take off the oil pan, and you have to loosen all the bearing caps, take off the rear bearing cap. There's a special tool you use to feed the seal in. You put it all back together, torque everything, put the engine back together. Two-piece seals are more prone to leakage than one-piece seals. That's why it's not uncommon on a car with a two-piece seal to be leaking oil at 70,000 miles. One-piece seals can go hundreds of thousands of miles without leaking. So you can see there's a big advantage. In the 1980s, GM changed their seal design on their small block Chevys, V8s. They went from a two-piece seal to a one-piece seal, and the books are not always clear. So it's not uncommon sometimes to go the wrong way on taking something apart and realize, oh, shoot, it's a different kind of seal. So always check the labor guide. Always look up the instructions. Don't assume what kind of seal you're using. Don't assume the transmission has to come out or the oil pan's coming off. Look it up, do some research, and hope no one put a different engine in. We also have what are called slingers. So some crankshafts use a slinger to cast oil for the oil return, so less oil goes to the seal. And this is on the crankshaft. We also see this on engines with a timing chain, for example, where we will actually have a little slinger that slides over the crankshaft between the timing chain and the front seal to try to limit the amount of oil that's pushed against the front seal. So slingers can be fixed to the crankshaft, or they can be a separate floating piece that slides on the crankshaft and is locked in place. We also see here that the rear main seal is just after that, before the flange. In this case, you can see the flange is much bigger than the seal. This would have to be a two-piece rear main seal. Other companies such as MG used a slinger but no seal. So MG used just a slinger to bring oil back, but did not use a rear main oil seal. So older MG vehicles, you cannot get them to stop leaking in their factory configuration. There is a retrofit kit out where you can now install a rear main seal kit on those engines to solve that problem. But from the factory, they did not have a rear main seal, which is very different than how we build cars here. But like I said, it's a global market. People build cars differently in different parts of the world. So oil pressure and level, instrument panel mounted oil pressure gauge or an oil pressure warning light, or both. Electric oil pressure gauge uses a sensor unit, then the water temperature gauge, obviously because we're measuring something different, but they, in theory and how they work, as we saw on in the electrical section, is basically the same. It's a series circuit, and I'm going to have a sensor that changes resistance. If it's a light, it's going to be open and closed. If it's a sensor, if it's a gauge, it's going to be a variable resistance to tell the customer what's going on. So if the oil light's on, that means we don't have enough pressure to open the switch. The switch defaults to the closed position. So if the oil light comes on, I should shut the car off immediately. We also have an oil gauge on some cars, which gives me a relative position. Oil gauges on dashes are not terribly accurate. So don't get concerned of, gee, it used to read 40 and now it reads 44. Who cares? They're really designed to show you catastrophic failure. They're designed to show if you have really low pressure, really high pressure, or in the normal range. Some of them, like GM, the oil pressure sensor actually goes to the powertrain control module, and then it shares that information with the powertrain control module with the instrument panel cluster through a bus or through a network. So here we can see an active warning light, register on the gauge, or turn on a warning message. Many times the warning message is telling you to look at the gauge or the light. And then we might even get a warning dinging or some kind of audible sound, because manufacturers really want us to pull over when we have no oil pressure. So we what? Don't destroy the engine. And even though when it's out of warranty, it's our problem. If it's in warranty period, it might be their problem. So they're really trying to limit costs. They really want our attention. And here we can see a couple of different schematics, one with the switch and one with the send unit. So on the left side, we can see how it would work to have the light on or the light off. And the bottom, I don't have enough, on the top, I don't have any oil pressure, so the switch is in contact. And then when I have oil pressure, now I'm able to open the switch and the light goes off. So it's a simple on-off series electrical circuit. The gauge is drawn here as again, a simple series flow circuit. We're using ground here to help power the gauge. And we're using what? A variable resistor. The more pressure I have, the greater the resistance, we're going to see higher voltage. So we can adjust how we want to set that. So low pressure is going to be high resistance, high pressure, low resistance on the gauge. So we're just changing the amount of current flow. So if I wanted to test either of these systems, first thing I do is I go to the send unit. I'd unplug it. What's the gauge or light do? I'd connect ground to it. What does the gauge or light do? It should do the opposite. If it does, that means the gauge, the wiring or light, everything's good. My problem is either I got a bad sending unit or I've got an oil pressure problem in the engine. At that point, I would take the oil pressure send unit out. I would connect a mechanical gauge. With the mechanical gauge connected, I would check that gauge reading against specifications provided by the manufacturer. If the readings are within specifications, I would put a new sending unit in it. If the readings are not within specifications, then it's time to do engine repair. Simple enough. Here's oil monitoring systems. Several manufacturers now have monitoring systems telling you to change the oil. Most of these are based simply on mileage and must be reset every time the oil's changed. So they can be as simple as in Toyota, I go to trip A, I hold the button in, turn the key on, and watch the little dots count down, and I'm reset for 5,000 miles. Some systems like Porsche at the other end, I need an OE level scan tool to reset their maintenance reminder. I can't do it without a factory level scan tool. Those are our two extremes. There's a lot of stuff in the middle there. GM, you turn the key on and you pump the gas pedal 5 times in 3 seconds. That reset the maintenance light. But you can imagine the confusion on the part of the customer if a week or 2 weeks after you change the oil, their light comes on, tell them they need an oil change. There's other systems that are intelligent service systems. Mercedes was a pioneer in this, and we see this in other European vehicles, BMW and so on, and we're starting to see it in Honda and some other stuff, where what kind of driving is this car getting? Is it all freeway driving? Is it all stop and go? How many days has it been? How many hours of engine operation has it been? And then for there, so your oil change interval might be in a range. It may turn the light on at 2,000 miles. It may turn the light on at 5,000 miles. Or some of the European systems may turn it on at 7,000 miles, may turn it on at 13,000 miles. So again, based on driving conditions, so that's the term condition-based service, it's going to tell the customer when to change the oil. And they're doing that not to make the engines last longer, but to lower the carbon footprint made by the vehicle and lower projected maintenance costs, so the car looks cheaper to own when someone's looking at buying a car, because they can use the most optimistic of every 13,000 miles. Yeah, it's $100 to change the oil, but you only got to do it every 13,000 miles. Or it's $200 to change the oil, but you only got to do it every 15,000 miles. So your cost of maintenance over 100,000 miles might look to be as low as a Toyota that you're changing oil every 5,000 miles on. Well, the reality is, how long is that engine going to last after that 100,000 miles? How many problems are you going to have with it? And oil's recycled. So we're not throwing oil away. So let's think about it. We're concerned about the carbon imprint. We're concerned about the environment, but yet the oil we drain out is being taken, recycled, and reused. It's not being stored as hazardous waste. It's not going somewhere. So where's the problem?
I read something like that even in California about the law for the environment, and they say it's like transmission is sealed 100,000 mile. Actually, you need, if you read the ZF is the factory who produced the transmission, they say you have to change the oil 65,000 miles. But Audi says 100,000 miles. You know what I mean? It's like,
well, the reason why
for permission to sell a car in California, I think.
Right. Well, and what they did is, what's interesting is a lot of these on transmissions, it's called lifetime fluid. Okay. You never have to change. It's good for the life of the transmission. Well, on my 1962 Chevy, that fluid was good for the life of the transmission too, because if I didn't change it, that fluid will last exactly as long as that transmission. The question is, how long do you want the life of the transmission? According to ZF, lifetime is 100,000 miles. So their fluid's only certified for 100,000 miles. So even though the owner's manual may say lifetime, the definition of lifetime by the people that are having the products made is 100,000 miles. And that gets them over what? That 100,000 mile cost of maintenance. See, that car is just as cheap to operate as a Hyundai or a Yugo or whatever. because they hide all that stuff. And you know what? If you're getting rid of the car at 80,000 miles, it's probably not an issue. You're going to keep the car for 200,000 miles, it's an issue. You know, so, you know, cars are expensive. They're expensive to buy. And I want to keep my car as long as possible. Why go buy something else? It's cheaper to keep the one I have. But that only works if I take care of it, maintain it, and it's reliable, right? So, you know, even a new Camry is what, 25, 30 grand, 33 grand, something like that. And that's a Toyota Camry. A Corolla is what, 18 to 22 grand? I mean, that's a lot of money for, I want to get some miles out of it. I mean, that's an awful lot of money, especially if you think someone's only going to keep that for 3 years, 4 years, 5 years. That's a lot of money every year. But I go spend $25,000 on a car and I keep it for 12 years and I get 300,000 miles on it. Now my cost per mile is not so bad, is it? And it's still worth something when I sell it. So for those cars that have sealed transmissions, what do you recommend? There is no car with a sealed transmission. All transmissions are serviceable, and all transmissions have a service procedure.
I mean,
so my recommendation to the question I was asked is just what Mario said: 60,000 miles. Let's change the fluid.
Was horrible. My car, like 80,000 miles, was horrible. I was like really on limit, I think.
Yeah, no, my wife's car is the same thing, and it gets changed. I don't, you know, the transmission in her car, because it's a Magnum, is a Mercedes transmission, very expensive transmission. And I know what the problems are with it. It gets new Mercedes fluid in it. And I've done it every 30,000 miles because she drives so little, because of how many years it is. I want to get the stuff out. And the fluid costs me, I think, $7 or $8 a quart. And it takes me 7 quarts, I think, to do it. So really, what, every 7 years or so, I got to spend $70, $80. It's a lot cheaper than putting a $4,000 transmission in it.
I changed like 20 liter I put in. I did like 4 times. You know what I mean? For better result, because it's like a partial. You can change partial fluid. No, you know.
I do the same thing on my Camry, which has a sealed transmission. There is a procedure to check it. There's a procedure to drain it. There's a procedure to fill it. And there's a procedure to check the level on it. So there is no such thing as sealed. We call it sealed because we don't want the customer to deal with it. Just like we have cars now that do not have a dipstick for the oil. You have to check the oil through the information system, because what? We don't want our customers checking oil because they're not going to do it right. We want the computer to do it. So a lot of the stuff that we're sealing, transmissions and other things, it's because we don't want the uninformed public to put the wrong fluid in. So a lot of these transmissions that are sealed use a special fluid that may only be used by that manufacturer or only by that transmission manufacturer in the case of ZF. So they don't want someone going to XYZ Auto Parts and putting the wrong fluid in and destroying a $5,000 transmission. So the safest way to prevent that is to keep it sealed. And can I show you that procedure sometime? Probably can. I don't get into transmissions in this class, but I can certainly cover it. The procedure varies by each manufacturer slightly. I need to make a phone call too. I don't have Mitchell or All Data here at the house right now, even though I have a subscription through the training company I deal with. So let me work on getting that, because then I can pull some stuff up and get you some information on that, because that's a good thing. And I can pull some of that. And sometimes, like on my Camry, it's like 20 pages, which is just stupid. And so I cheat. And I cheat the same way the dealers cheat. If I have no leaks, and so I haven't lost any. If I drain some fluid out and I put
the same amount you drain, the same amount you put in.
Right.
I did the same, because it's not driving you crazy.
Right. So if I'm just doing a service on a car with no leaks that I know is full when I start, I can cheat. And that's what the dealers do. If I'm doing an actual service where I pull things off and I don't know what it is, or it's low, then I have to follow the procedure. And the procedures, depending on the manufacturer, can be very confusing. But on my car, I cheat. Why? I looked at the directions. I go, wait a minute. I don't have a problem now. I'm going to drain out. I got one of those painter's pails that has all the ounces in it. I drain out. I see exactly how many ounces, and I put exactly that many ounces in. I'm good to go.
And even if the fluid deteriorate a little bit, in like 10 liter, 11 liter, it's like, it doesn't matter 300 gram or more, 300 gram less. I think it's like.
Yeah, no, you want to be close. I mean, you want to be, again, the transmission fluid is normally measured in half a quart or, or a pint. So if I'm a couple ounces off one way or the other, it doesn't matter. I don't want to be severely underfull. I don't want to be severely overfull. And my transmission level is really dependent on temperature. So all these sealed units all have me go through, use a scan tool and verify the temperature. And I can only check my temperature in a certain range. I can't be too cold. I can't be too hot. So like on a BMW, if I'm actually checking the temperature, it might take me half a day to check it, top it, let it cool back down so I can recheck it. It's a half a day on the rack. It's ridiculous. But that's the only way to correctly do it. But I can get into some of that. Remind me on that later. I'll try to get some stuff up on that. So cooling the oil. Carbonizing or coking excessive heat causes oil to form lumps that clog the pickup screen. So moisture contamination can cause that. Oil burning can cause that. Obviously, I like synthetic oils because they're not going to carbonize or coke as easily as a conventional oil will. Years ago, by years ago, I mean like 80s, actually early 80s when Mobil 1 came out, they actually took a frying pan and they put conventional oil in the frying pan and Mobil 1 in the frying pan, and the conventional oil, it all burned, and the Mobil 1 still poured and looked good. So that really shows you the difference between a synthetic oil and a regular petroleum-based oil. So one of the things you get aside from the protection package, longer life, is it's not going to burn or coke as easy. Yeah, Mario.
What about this cooling? I use it carbon cleaning. They work this stuff.
Carbon cleaning is something that's totally different. So if I'm going to clean carbon, I'm going to do that with the intake, and I'll talk about that some when we get into induction systems and fuel. They do have additives that go in the oil that's supposed to clean the inside of the engine. I am not a fan. I've seen a lot of engines destroyed from that.
The best way is like change often the oil.
Yeah, change the oil. What we used to do in the old days, I wouldn't do this on a modern car, but if I drug an old 60s or 70s car out of somewhere, what we used to do is we actually used to fill them up with transmission fluid and drive them on automatic transmission fluid for a couple 100 miles and then drain it out. Because transmission fluid has a lot more cleaning properties than engine oil does. So that's what we used to do. Or you put 1 or 2 quarts of transmission oil in with the engine oil to help clean. That's what we used to. I would not do that on a modern car, but on a 70s, 60s, 70s or older car, yeah, you could certainly get away with it. That's what we used to do. We didn't have all these fancy additives. The issue with a lot of the oil cleaners that you put in, they're designed to be put in, run the engine for about 5 minutes and drain it out. They're heavily acidic, and that's how they get the oil sludge and stuff to break loose. The two issues I've seen is one, draining it out and putting fresh oil in it, you're not getting all the acid out, so that stays there. The other issue is we've seen sludge and other things break loose on cars that are extremely compromised and plug up the screen 1,000 miles after the oil change and cause the engine to blow up. So I am not a fan of oil cleaners. I'm not saying I've never used one, and I'm not saying I've never used it for a customer, but I could probably count the number of times I've used it in my career on one hand. I bet you I haven't used it 5 times. I mean, very, very rarely have I done it. And I personally know of at least 4 shops that have eaten engines from oil flushing.
The ones in the gas, the carbon.
Those are fine as long as they're okay for modern fuel pumps, and pretty much they almost all are now. You want to be careful with fuel additives. A lot of them are just a high level of alcohol, and what that's going to do is it's actually going to cause your fuel
Knocking.
to go a little nuts. Alcohol is great at getting rid of water. So if I think I have water in the fuel, that'll do really good. The alcohol is hard on other components and is not the best cleaner. There's other chemicals for in-tank fuel system cleaners that are much better. Techron is one of the best out there, which is made by Chevron. Again, Chevron's a chemical company. They invented it. Other companies, including Mopar's factory cleaner, is Reebok's Techron. So Techron is an excellent product for that. It's completely safe. Lucas makes a fuel injection cleaner that's good and completely safe. I use a Streamline Products cleaner, which is only available commercially to shops. Again, safe, very effective. There are some good ones out there. A lot of the less expensive ones, if you look at the content, they're 90, 95% alcohol. That's not what you want.
Thank you.
No, all kinds of good stuff. So oil cooling by airstream passing over a thin pan, thus drawing heat out of the oil. Some oil pans have fins cast into them to aid in cooling. We see that on some Honda Odysseys and some other cars. Some cars use an auxiliary oil cooler. One of the real common ones is this style here, where it actually screws in and mounts underneath the oil filter. So Nissan used that. What is fins cast? Okay. So if I had, instead of having a flat piece of aluminum, it has fins like this cast in the bottom of it, which creates a larger surface for the air to flow through and dissipate the heat. You say Lucas Fuel Injection Cleaner is good? Yes, Lucas Fuel Injection Cleaner is good. Used it for years with very good results, and it will not damage components. Someone else said they like the Techron. Techron is awesome. Techron was revolutionary when it was invented almost 30 years ago, and it's still really premier on the market. Remember what I said when we were talking about oils? Chevron is a chemical company that happens to produce oil. So they really do some phenomenal stuff. Matter of fact, even if you're into gardening, you'll see Chevron makes different chemicals for gardening stuff, for pesticides and things like that. Chevron's a huge chemical company. So they, fascinating, all the things they do. In this case, this particular one, cooler, uses engine coolant to cool the oil. So these are nice because they're fairly inexpensive to install for the manufacturer. They have the two coolant hoses, so they had to do a little redesign there to get hoses to it. But they're just putting it on the oil filter housing. There's a seal that goes between this and the engine block that'll leak, very common on Nissans. And then the oil filter screws on. So again, very serviceable, very easy. I don't need to run lines from the engine all the way to the front of the car, put more stuff up in front of my air conditioning system or radiator. So if these are compact and have gained a lot of popularity. Occasionally these will go bad and mimic a blown head gasket, where you'll actually get coolant into the oil and it'll look like you have a blown head gasket. Your oil looks like a chocolate milkshake from McDonald's. And people will think they have a blown head gasket. In reality, it's the oil cooler. So that's very, very common. We've been using these coolers since the 90s. Very, very common problem with them, especially on a lot of European cars and other cars that don't normally have head gasket issues. It's almost always the oil cooler that's bad, not the head gasket. So the lesson here is that if I have oil that's contaminated, it looks like a milkshake, I have coolant or water in the oil, that is a symptom. It's not a diagnosis. It's up to us to diagnose. So if I thought that was it, what I'd probably do is I would bypass the oil cooler. So I disconnect the hoses, route it around it, and then I might run it, see if any oil comes out. If oil comes out, I know that it's bad. If no oil comes out, I'm going to change the oil, put a new oil and filter so it's clean, let the customer drive the car, have them come back in 200 miles or 500 miles, and let's see what the oil looks like. If it looks like a milkshake, we got to take the engine apart. If it looks nice and clean, we need a new oil cooler. So process of elimination. I can also take this off and use my cooling system pressure tester that I'll talk about later on this week, and actually adapt up to actually put pressure in there, and can that hold pressure where the coolant's supposed to go or does it have a leak? So I have a lot of different ways I could diagnose it based on the tools I have.
No, the last one, I don't understand really.
Coolant is cooled by air or coolant, depending on design.
Mm-hmm.
Okay, so this is cooled by coolant.
Oh,
This
okay.
is cooled by air.
Okay.
All right?
Yes.
Good question. I just had to let me get there.
Mm-hmm.
So do you all know a lot more about engine lubrication now?
Mm-hmm. Yes, usually the motorcycle have like this height,
Yes.
this one.
Yep. Yeah, my Harley has one on it.
Mm-hmm.
So let's look at a poll here, and I'll give.
I don't really love all this equation. The school is like that.
What's that?
I says I don't really love all this equation
Oh,
sometimes, but the school is like also that.
well, if you notice, a lot of times, Mara, I ask you the same question several times or several different ways. And part of it is because we learn, and part of it is because we're trying to, I want to reinforce, or if people aren't getting something, it's a chance for me to teach it again.
Mm-hmm.
And that's like, so the quiz here that I'll turn on for lubrication, where all these questions are going to be on a quiz, is a way of rewarding you guys for being in class, paying attention. They're almost free quiz points.
Thank you.
But what it does, it allows, if I say something once, I probably won't remember it. But if I say it 10 times, I probably will remember it. And I'm a big believer on learning by repetition. Just like we were talking earlier about, I look very comfortable when I change the battery. Well, I said, because I've done it a lot. I want you to be very comfortable with the quizzes and very comfortable with the information because, oh, I've answered this before. I know this. And I want everyone to be just as comfortable as I was. I do see if I can explain the level 2 assignments. So I will do that after the quiz. I'll share my screen and do that. And I did make some changes to them to make things easier for you to submit. So we got about 1 more minute here, and I'm still missing 15 people. Don't know what you're doing, but the quizzes have disappeared. The one we're working on now? Huh. Maybe you hit submit. I don't know. Okay, well, you'll see it when I come back and share it with everybody. Okay, we got about 30 seconds. Still missing 10 people. Or maybe I didn't miss anyone and only the people that are actually here participating, the people that are pretending to be here didn't. All right, so another 10 seconds. And we only got 78% of us. I'm still missing 8 people. Okay, so let's share some results here. So modern synthetic oil is over 50% additives. That is true.
Yes.
Which of the following oil weights is the thinnest? That would be 0W20 is the thinnest oil. The bigger the number, the thicker the oil. Remember we were talking yesterday about you guys just said the 0 winter 20? Well, I know where I got the weight and you got the winter. It used to be winter weight, 0 winter weight.
Oh,
So I remembered the weight and the books remembered the winter apparently. So
Well, the book wants to see winter as an answer on that question, though.
yeah, and that's fine. But that explains why I'm disconnected from the book. Because I went back and looked at some of my old stuff from 40 years ago.
Yes, when I did my my pre-test, it's asking the very same question in it wants winter.
It wants winter. Okay. But the concept is winter, I need thinner oil because it's colder out.
Right.
So that's why the lower number is always first, because that's the thinner oil. An API rating of SN indicates the oil can be used in which of the following types of engines? And the correct
Gasoline.
answer is both gasoline and natural gas, because it is
Oh.
for spark ignited engines. The
One
only engine that we combustion ignite is diesel. Well, therefore, everything else gets
Huh?
S series oil. If I'm putting in a diesel,
Hell
it has to
yeah.
have a C for the first
Got
letter.
that one right.
So that was my
Hmm?
trick question of the day.
Tricky.
Oh, I thought it's in the chart.
Yeah, so
correct.
right. The chart, the S chart, S stands for spark ignition. So we use spark to ignite propane. We use it to ignite natural gas. I use it to ignite alcohol, and I use it to ignite gasoline. I do not use it to ignite diesel. Diesel is ignited through compression.
Compression.
So that's why the diesel oils, the certification starts with a C for compression. Everything else starts with an S for spark. And I tried to go over that yesterday. And that's why I put the question here, because I wanted to reinforce that.
Oh, it's tricky.
Because I can see that less than half you picked up what I was laying down yesterday. So that's another reason why I put these questions in, Mario, is for me to go back and make sure I don't lose anybody.
I know.
Manufacturers may have additional specifications on top of the API rating for the engine oil. Yes, absolutely. We talked about that yesterday with GM's Dexos. I talked about Mercedes with 229.5. We talked about Audi, Volkswagen. We talked about Porsche. A lot of manufacturers do that.
Doon ka, angat dyan.
In fact, you may have additional.
So I had several microphones going at once there, so I muted. If you got something to say, just turn it back on. On the friction bearing system, oil is used between what two components? And that would be the bearing and the shaft. So the shaft that is rotating in the bearing is where the oil is. So bearing and shaft is correct answer. What type of oiling system is used on modern automobiles? And that is a combination of pressure and splash lubrication. I tried to reiterate that several times because we have the things with high pressure get pressure lubricated. The things with low pressure on them, such as rocker arms, timing chain, things like that, are splash lubricated. Which oil pump design is mounted in the front of the crankshaft? And that would be the crescent style. And the book goes into that, and that's what was in the PowerPoint. The vane style is only used in automatic transmissions. We don't use that on engines at all. And then we also use the rotary and gear style, which has 2 gears.
Which
And those
one?
are normally mounted separately on the engine.
Which one is used?
On the front of the engine is the crescent style. And that's in the PowerPoint presentation that we finished yesterday and put up. Actually, I don't have it posted yet. It was still editing. It hadn't gotten done editing.
Then, Mr. Brian,
The PowerPoints are up, but the presentation is not. What Itzel?
then rotary and gear is mounted on the side?
Yeah, they can be mounted on the side, or some of the gear ones are mounted, or rotary ones, I'm sorry, are mounted in a cassette with a separate chain underneath the crankshaft on some cars. But they're not going to be mounted on the front of the crankshaft.
Oh, okay. Thank you.
According to the diagram, and correct answer on that is lifters. Lifter is the last thing to get oil pressure after the camshaft. Remember I talked about we want stuff that makes noise and lets the customer know before we have catastrophic damage. So the lifter is normally is going to get oil pressure after the camshaft. Camshafter has high pressure oil. It's rotating. If it was the last thing to get oil, it would be the first thing to fail. So since our lifters are the last thing to get oil, they can make noise. And yet once I fix the oil pressure problem, the lifters will still be fine. They're not going to be bad as long as I catch it soon enough. Where if it was a camshaft and it lost oil, 20 seconds, a minute, I need a new camshaft, maybe a whole new engine. So the last thing that gets oil is something that we want to get the customer's attention or get the technician's attention that there's a problem before it becomes catastrophic.